Starting with the pop quiz 9, which was related to atomic physics and space physics. The first question: how do sizes of the two nuclei produced in a nuclear fission reaction compare with the original nucleus? So when we compare what actually happened in a nuclear fission reaction, in a fission, the heavy nucleus break down into lighter nuclei by the help of neutron. So if you compare the two nuclei which are produced, like the product, in a nuclear fission, so what will happen? Compared to the original, they will be small, like it both smaller than the original nucleus. Like original nucleus will be bigger, but when by the help of a neutron, when we break down the heavy nucleus into a lighter, by the help of neutron, we call that as a nuclear fission. So the products, the nuclei which is produced, that is, or the two nuclei which are produced, they have a smaller size, or few nucleons are there. So both are smaller than the original nucleus. That's why option C is the right answer. In question 2, which statement about the radioactive decay of a substance is correct? So whenever there is a radioactive decay, which statement is correct? It cannot be predicted when the particular nucleus will decay. That's correct, because radioactivity is random and spontaneous. So when we say random, means there is no order. We cannot predict when the next nuclei will decay. Placing a radioactive substance, so A is the right answer. Why not B, C, or D? Placing a radioactive substance inside a lead lined box prevent it from decaying? No, we cannot stop it to decay. We cannot change the like a container is there made from lead, or any lead lined box is there, so it will not absorb the radiation from the radioactive source, but it will not prevent from decay. So this is not the right state. The decay always produce a poisonous gas. That's totally wrong. The rate of decay increase. No, the rate of decay always decrease with time. Like in the beginning, maximum activity or greater rate of a decay, like more radioactive nuclei will decay, but with the passage of a time, the number of the nuclei decay will decrease. That's why A is the right answer. In question 3, the diagram shows stream of a beta particle. So for beta particle, what we will use? We will use a right hand. So for right hand rule, your index finger or your first finger represent the direction of a magnetic field. Magnetic field is from north to south, so your index finger of your right hand pointed downward. Second finger represent the direction of the particle. Which direction the beta particles are moving? They are moving towards right. So your index finger is pointing downward and your second finger is pointing towards right. Where your thumb is pointing, when you check where your thumb is pointing out of the, like it's pointing towards you, the right hand, or out of the plane of the paper. So that's why D is the right answer. Is it clear, this one?
Yes, sir, clear.
In question 4, you have to use the right hand, not your left hand, because it's a beta. For beta, you should use your right hand. Your first finger, your index finger, in this example, point in the direction of a magnetic field. So your index finger should point downward of your right hand. Your second finger point in the direction in which the particle is moving. So beta particles are moving towards the right hand side. So your second finger is pointing towards the right hand side. Where your thumb is pointing, that is important. So when you check the thumb, you will find automatically when you apply the rule, index finger is pointing down, second finger is pointing towards right. your thumb is pointing out of the screen. That's why it is out of the page. So you have to use your right hand. So your index finger pointing downward. So your first finger or index finger pointing downward. Your second finger is pointing towards the right hand side. Where your thumb is pointing, your thumb represents the direction. Your thumb represents the direction of the force or the direction of the deflection. In question 4, a distant star exploded as a supernova. Which statement is not correct about the supernova? The exploding supernova form a planetary nebula. No, it does not form a planetary nebula. The distant stars is large when compared to sun. That's right. Because if it was a sun-like star, then what will happen? There will be no supernova. So the distant star is large like this. Because when we talk about the life cycle of the massive stars, first we have a protostar is there, then it will be a main sequence star, then it will be a supergiant, and then supernova. But for a low mass star or sun-like star, first it is a protostar, then main sequence star, then it will be a red giant, and then planetary nebula, which might result in a neutron star, which result in a formation of a dwarf neutron star, or a black hole is there in a massive. So first statement is not correct, like exploding supernova forms a planetary nebula. No. This is correct statement. Yeah, planetary nebula or nebula is the same idea. Supernova release heavy element into the space. That's true. The supernova leaves behind a neutron star or a black hole. That's also true. So these three statements are correct. Which is not correct statement? A is not the right statement. In this question, the distant galaxies are moving from the Earth at a very high speed. The graph P and Q shows how the speed of the galaxies changes with their distance from the Earth increases. Which row are the statement about the Hubble constant and age of the universe? So when we talk about like a gradient, what is a gradient? Remember, whenever you're taking a gradient of any graph, gradient is quantity on y-axis divided by quantity on x-axis. And what we talk when we say about area, area is a quantity on y-axis multiplied by x-axis or x into y. It does not make difference. X into y or y into x. Now, Hubble's constant. What is the Hubble constant? According to Hubble's law, speed is equals to Hubble constant times d. So speed divided by distance is equals to Hubble's constant. So speed and distance graph, if we have a speed and distance graph and we take a gradient of this graph. So when I take a gradient of this graph, gradient will be quantity on y-axis divided by quantity on x-axis. What is on y-axis? On y-axis we have speed. What is on x-axis? On x-axis we have distance. So speed divided by distance. Speed divided by distance, that is Hubble's constant. So the gradient of speed and distance graph, what it gives us? It gives us the Hubble's constant. And what about the age of the universe? When we talk about the age of universe is reciprocal of the Hubble constant, or we can say, because we have the formula, speed of the galaxy is distance divided by time. So if we need time, time is distance divided by speed. So distance divided by speed will give us the time, and this time is refers to the age of the universe when we talk about the galaxy speeds and their distance. So that how much time it took, that is like the age of the universe. So when we take the gradient of this second graph, when we find the gradient of the second graph, it is y divided by x. So on y-axis, we have distance. On x-axis, we have speed. So what is distance divided by speed? Distance is divided by speed is time. So the gradient of this distance, speed, time graph will give us the time, and that time is the age of universe. So when we take a gradient of the first graph, which is quantity on y-axis divided by quantity on x-axis, that gives us the Hubble's constant, because speed divided by distance. And when we take a gradient of the second graph, it is distance divided by speed. And what is distance divided by speed? It is time, or in case of the galaxies, it is refers to age of universe. So when we take the gradient of the first graph, we get Hubble's constant. And when we take a gradient of the second graph, we get the age of the universe. Is it clear, this one? About the Hubble's constant and the age of universe? Anyone having a doubt or a question in this part? Why it cannot be area of the graph? Area, because as I mentioned, area under the graph, it is making a triangle. So when we take area under the graph, it will give us half, because it's making a triangle, half speed into distance. So speed into distance is not the Hubble's constant. Hubble's constant is speed divided by distance. So that's why not area of this. When we take the area of this graph, it will be half base into height. So it will also be speed into distance. Again, half speed into distance does not give us any quantity. So any part with the area is totally wrong. Like options in which area is written is totally wrong. So when we take a gradient, whenever you remember one thing, whenever you take a gradient of a graph, gradient is quantity on y-axis divided by x-axis. So this will be speed divided by distance. So speed divided by distance is a Hubble's constant. And when you take a gradient of this second graph Q, that is also y divided by x. So on y-axis, we have distance. On x-axis, we have speed. So distance divided by speed, we get the time. Because we have the formula speed is distance over time. So time is distance divided by speed. So that time is the age of universe for galaxy. So gradient for Q represent the age of universe, and gradient of P represent the Hubble's constant. In question 6, in a nuclear fusion reactor, a nucleus of a hydrogen fused with a nucleus of hydrogen 3 at an extremely high temperature. Why extremely high temperature is needed when forcing these two nuclei together? Like, because in a fusion, what happened? We bring the two nuclei together. So why we need a high temperature? What is the reason for that? Because the nucleus contain identical or a positive charge, as there are protons present inside the nucleus. And protons are identical particles, they like charges, and like charges repel each other. So why we need a high temperature? When we increase the temperature, the particles or the nucleus or atom will move faster. As a result, they can overcome the repulsion between the two, like each other. And so they can collide with each other, or they can fuse with each other. So what are the points you should mention? Like nucleus contain identical charges, and the like charges repel each other. So to overcome the repulsion, high temperature is used, which increase the speed. So these nuclei can easily collide with each other. Otherwise, if the temperature is too low, the repulsion is very high. Like example, this is hydrogen 2,1 is there, which is having 1 proton, 1 neutron, and hydrogen 3,1 is there, 1 proton and 2 neutron. So proton and proton are repelling each other. We want to bring them closer. So how we can bring them closer? So if we increase the temperature, so normally for a nuclear fusion, two things are very important. One is a high temperature, another one is a high density. High density means more particles will be there. High temperature means particles will move faster so they can overcome the repulsion. Is it clear, this one? Why we need a high temperature for a nuclear fusion? In this question, figure 1.1 shows the orbit of a comet, as you can see from different positions, X, Y, P, and Q. State how the speed of a comet changes from X to Y. Look, at X, it was far, so it will have higher potential energy and lower kinetic. But at Y, it is closer to the sun, so it will have a smaller potential. Kinetic energy will be higher. So when it moves, so as it moves from X to Y, what will happen? The speed will increase. Explain in terms of energy transfer your answer to A1. So how we explain, it's of 3 marks, and how you will score the 3 marks. First thing you will mention that the total energy is conserved, like total energy is constant. Then as the comet is moving closer to the sun, the potential energy decrease, so the kinetic energy increase. As a result, the speed will also increase. So we'll mention the total energy is conserved, or you can also say constant. So moving from X to Y, the potential energy decrease because it depends on the position or height. So it is closer, gravitational potential energy decrease. So kinetic energy will increase. And when the kinetic energy increases, it means the object will move much faster. The shape of the orbit of comet from P to Q is circular with the sun as its center. State and explain the change, if any, in the speed and in velocity. From P to Q, because the distance of comet from at position P to the sun and at position Q to the sun is same. So means the potential energy does not change, so kinetic energy won't change. So the comet will have the same speed. The speed of the comet won't change because there's no change in kinetic energy. So speed at P will be same as speed at Q. Like if I say speed is 10 meter per second at P, it will have a speed of 10 meter per second at Q. But what will be different? The velocity will be different because the direction has changed. Velocity is a vector quantity which depends on the direction. So how the speed changes, speed will be same or constant. And why? Because there is no change in kinetic energy. But for velocity, it will change. Why it will change? Because the direction changes. So whenever object changes the direction, there is a change in velocity. Like so, if the comet was moving at a speed of 10 meter per second, and at this position also it is having a speed of 10 meter per second, so speed does not change. But what happened to velocity? It changes because the direction is different. So if the direction change, there will be a change in velocity. Is it clear? This pop quiz 9, which was related to atomic physics and space physics.